What is up, everybody? It's Dan from SageMathTutoring.com, and here is a video for a student of mine who has a test literally tomorrow, and this is based off of his review sheet. So I say we dive right into it. So this one says write as a complex number in standard form. So complex number in standard form always looks something like this, where that's the real part, R for real, and that's the imaginary part. So we want to whittle this down until it looks something like that, where that's just some number, some integer, or maybe even a fraction, and then you have an imaginary part right here, and there could be a coefficient, and that's fine. So let's see what needs to be done here. Bottom line is there's an invisible positive 1 right there that could be distributed into the parentheses. And the same goes for this one. So we could rewrite this thing only without parentheses, and we could rewrite this thing only without parentheses. This one's a different story where we're going to be distributing a negative into both of these numbers here, into both of these terms right here. So I'm just going to kind of do all that on the next line right now. So that's going to be 3 minus 2i plus 2i, and that's going to be all over negative 1 plus 7i minus 2 minus 3i. Okay, so when you are trying to simplify a large complicated fraction like this, you are going to want to certainly simplify the top and bottom first before moving on. So the top would simplify to just 3. Hopefully my student at home can see that because these would cancel. And the bottom would become negative 1 minus 2. Well, what is that? Negative 1 minus 2. That is negative 3. And there would also be this positive 7i minus 3i, and that becomes positive 4i. Now, just for my own sort of brain, to help my own brain, I'd rather rewrite this as 3 over 4i minus 3, at least for now, just because to me that's a binomial that's a little less annoying to think about, whereas the negative 3 plus 4i. I have, for some reason, an attachment to the first term being positive. So you don't have to do that, but I'm just going to rewrite it. So the problem is that this still does not quite look like this. Okay, we want to get this green one to look like this. But, and really, another problem is the fact that there's an I in the denominator. Now, typically the teacher does not want an I to be in the denominator. And when you have a binomial in the denominator, the way to make sure that there isn't an I in the denominator is to multiply the top and bottom by the conjugate. And the conjugate is the exact same two terms, only it's plus in between them. You know, the opposite sign, in other words. All right, exact same two terms, only change the operation, I should say. Okay, if it's subtraction, it's going to turn into addition. If it's addition, it's going to turn into subtraction. And what that results in is the top, of course, becoming, let's just get this over with, it's going to be 3 times that and 3 times that. So that's going to be 12i plus 9. But then the question is, what about the bottom? Well, the bottom, the whole reason for multiplying by the conjugate is really because of the difference between two squares. So, as my student at home knows, a squared minus b squared, that's called the difference between two squares. And that could always be factored into a minus b times a plus b. Now, it's possible that my student at home is mostly used to seeing something like the difference between two squares and just being like, oh, okay, if it's x squared minus 64, well, that's going to be x minus 8 times x plus 8. And in other words, my student at home might be used to moving from this position to this position, but my student at home might not be used to moving from this position to this position. Okay, from this position to this position. Well, that's exactly what we're actually going to do here. And in fact, that's the whole point of multiplying by the conjugate, is because now we can just write 4i squared minus 3 squared. Okay? That's what happens as a result of this, because we're moving from this position to this position, from this position to this position. So, therefore, it's going to equal, still have that 12i plus 9, and this is going to become 16i squared minus 9. And then the question is, well, what is 16i squared? Well, 12i plus 9 is still up top. And that's going to be 16 times negative 1 down below, minus 9. And that's going to become still 12i plus 9 up top. And then we're going to have negative 16 minus 9, which becomes negative 25 down below. Now we're still not quite done, because what we could do from there is, first of all, recognize that we're getting closer to the complex number in standard form, where the real part and the I part, the imaginary part, are represented. This is about to be, the numerator of the real part. This is about to be the numerator of the imaginary part. What I'm going to do is two things before we proceed. First of all, let's get the top to at least look a little bit like this standard form, where the real part comes first and then the imaginary part comes after. Now, you don't have to do that, but I'm going to do it just to sort of get a little bit closer to our end goal. So we have 9 plus 12i, and we have a negative 25 down below. Now, the truth of the matter is, anytime you have a negative denominator, well, it's really because there's a negative 1 that's being multiplied to the denominator, which in a sense makes the whole fraction negative, and you could apply that negative to the top. So in other words, imagine for a moment, and this is an unrelated situation, imagine for a moment that you had a 3 over negative 5. Well, that's equal to negative 3/5, and that's also equal to negative 3 over positive 5. Hopefully my student at home realizes that all three of these are equal. Okay, all three of these are the same. It doesn't matter where you apply the negative. It could be on the bottom, it could be on the top, but or it could be straight off to the side, which implies that it's either on the bottom or the top. But the one thing that's for sure is it can't be on both. Now, the reason why I'm talking about this is because I would actually rather, quote unquote, apply this negative to the top, and that way we would distribute it across the top. All right, so let's just forget this for a moment, and we're going to focus here. What if we applied the negative to the top? Well, that would be negative 9 minus 12i. All right, all over positive 25. Okay, and then finally what I would do there is I would split this fraction, because this has two terms. We're going to split this so that it has two terms. So it's going to be negative 9 over 25 minus 12 over 25i. And then you are done, because this is the real part. The real part is negative 9 over 25. And the imaginary part is negative 12 over 25i. Hopefully that makes sense. Okay, so complete the square. So this says x squared minus 9x minus 2. Whenever you complete the square, most teachers would have you add 2 to both sides to send the constant over to the right-hand side. So after doing so, what you're really going to have is this. Now you might be wondering, well, why am I writing a space here? Well, I'm writing a space here because something's going to go here in a moment. What is that something? Well, it's always going to be the middle term divided by 2, the middle coefficient, I should say, divided by 2 squared. And what is that? Well, the middle coefficient is negative 9. When we divide it by 2, it becomes that. And then we're going to square it. Okay, now, truth of the matter is negative 9 over 2 is 4.5, but I'd rather not deal with decimals. Let's just call it negative 9 over 2, and then we're going to square it. So that's going to become 81 over 4. Okay, 81 over 4. So we're going to add 81 over 4 to each side. So it's going to be plus 81 over 4 plus 81 over 4. So then you might be wondering, well, what do we do from there? Well, now we're perfectly set up. There's an invisible 1 here, so we don't have to do anything fancy with this. Now we're set up to go ahead and factor this into something squared. And that something is always going to be x. And then, when it comes to this number, just know it's always going to be the number that you got after the first step with this middle coefficient. The first step was to take -9 and divide it by 2. And then you squared it, right? So we want to pay attention to that first step that we did before we squared it. The first step was to divide -9 by 2. So that's going to be -9 over 2. Okay? So just remember, this number is going to be whatever that first step was before you squared it. Okay, then focusing over here, we have 2 plus 81 over 4. Now 2 is secretly, 4, actually, 8 over 4, I should say. Okay, so 2 is secretly 8 over 4. And the reason why I'm kind of thinking about that is because I want that common denominator right here. So 8 over 4 plus 81 over 4, well, that's definitely going to be 89 over 4. So that is the right-hand side of the equal sign. At this point, we want to square root both sides. Square root, but we have to do this plus minus thing. Now, by square rooting both sides, the square root symbol on the left-hand side cancels with the exponent of 2, and then we're left with x minus 9 over 2 equals plus minus radical 89 over 4. Now, we can simplify this, and in fact, we should simplify this, but I'm going to wait till the very end to simplify that. Before I simplify it, what I'd rather do is add 9/2 to both sides. And that's going to give me x equals 9 over 2 plus minus radical 89 over 4. Now what we're going to do is bring this up here, do a little divider. Now what is this scenario? We have x equals 9 over 2 plus minus. Now let's kind of think about what this is. This is really radical 89 over radical 4. Due to the laws of exponents and square roots and radicals and all that, it is the case that you could split it apart in that way. Now, when you split it apart in that way, it's very obvious that this becomes a 2 down below. So we have x equals 9/2 plus minus radical 89 over 2. Okay. Now, let's just kind of think about 89. I'm curious to know whether or not 89 has any square root factors. Actually, I should say whether or not it has any perfect square factors, and it turns out that 89 does not have any perfect square factors. And in fact, 89 turns out to be prime. Okay, now one of the ways that I know this is I use an app on my phone called Simple Factors, plug in 89, and it turns out the only factors of 89 are 1 and 89. So there's nothing I could do to simplify this radical. So this is actually the answer right here. Hopefully that makes sense. Okay, this also is going to be the same directions. 2c squared minus 12c plus 6 equals 0. So let's see. We're going to want to, we're definitely going to want to send the constant over here. But one thing I didn't mention before is that whenever you're solving for a c, if it's like a quadratic trinomial like this, really what you want to do is just check and see, oh, is there any GCF that I could factor out of the whole thing and therefore make my life easier? Well, it turns out, yes, you can factor out a 2, and in doing so, it becomes this. 2 times c squared minus 6c plus 3 equals 0. And then what happens as a result of that is you can now divide everything by 2, and that cancels the 2's, and you're left with c squared minus 6c plus 3 equals, ready for this, 0. Okay? Because 0 divided by 2 is just 0. That's a lot easier to deal with than this thing. All right? So now we're still going to complete the square because the directions on the worksheet did say to complete the square. We're going to go through the motion. C squared minus 6c equals negative 3 over here. We're going to divide negative 6 in half, which is negative 3. We're going to square that, which is positive 9. So that's going to become plus 9 plus 9. Okay. So then we're going to have c minus 3 squared equals 6. Okay. Now, how did I get that negative 3 right there, or minus 3 right there? Well, again, it was the first step that I had performed earlier. What was the first step? To take the middle coefficient, divide it in half, and then square it. So we're interested, when it comes to this number, in what was the first step? Well, the first step was to divide negative 6 in half. What did you get? Well, you got a negative 3 before you squared it. So that is the number that we're going to put right there. Same deal as before. We're going to square root both sides. Now, obviously, we have to do this plus minus thing. And then it becomes c minus 3 equals plus minus radical 6. And bringing it all the way back up here, it's going to be c equals, after adding 3 to both sides, we're going to have 3 plus minus radical 6. And that is actually the answer. And the reason is because radical 6 has no perfect square of factors. Therefore, this cannot be simplified anymore. Moving on. Okay, so believe it or not, this is a similar situation where we're going to divide everything or factor out a 3 first. So it becomes that. And then it becomes this. All right, put these lines through here. It becomes that. Put a line through there too. And then you just go through the motions again. So I'm just going to do it like relatively quickly. That's going to become positive 3 or negative 3 over there. And then we are going to take negative 1, divide it in half, and square that. Well, that's going to be plus 1/4. Plus 1/4 on each side. And then when I sort of factor this one, it's going to become z minus 1/2. Right? Because that was what we did first with this thing. It was negative 1, then we divided it in half, so we put it right there. And then we have negative 3 plus 1/4. Well, you know, negative 3, I'll put a little asterisk near it. Negative 3 is secretly negative 12 over 4. And I want that common denominator right here. So negative 3, since it's negative 12 over 4, I could think of it as negative 12 over 4. So negative 12 over 4 plus 1/4 is going to be negative 11 over 4. All right, negative 11 over 4. Then I'm going to want to take the square roots of both sides, plus minus, and as a result of that, I end up with z minus 1/2 equals plus minus radical negative 11 over 4. Now that's going to turn out to be an imaginary number, which we're going to worry about at the end. Let's add 1/2 to both sides. As a result of adding 1/2 to both sides, we will get z equals 1/2 plus minus radical negative 11 over 4. So this is kind of a weird situation because, again, I'm going to want to split the radical to apply to the top and the bottom and kind of take things from there. And also, I'm going to just make a decision. We're going to call the numerator negative and the denominator positive for the same reasons that I said before. Negative fractions can be written in 3 ways. You can either see the numerator as negative and the denominator as positive. You can see the numerator as positive and the denominator as negative, but you can't see both, okay? And really a third way of writing, at least, a negative fraction is to have the negative right next to the division symbol. But the truth is that either the numerator or the denominator are negative, with the other being positive, and that's the case for all negative fractions. So what we're going to do here is bring this up And I am actually going to split this. So it says plus minus radical negative 11 up top all over radical 4, right? Again, you can split this to the top and bottom. And in fact, you should split this to the top and bottom. And the reason is because we don't like radicals in the denominator. Even though it doesn't look like it, since the radical is going over this whole fraction, there's secretly a radical being applied to this denominator, but we don't want that. Okay, we don't want that. You're not allowed to have that, actually. Okay, you don't want radicals in the denominator. For your final answer, you have to get rid of the radical that's in the denominator. So we're kind of splitting it so we can very clearly see what's happening in the denominator. And really, it's just the square root of 4. So what we're going to get is 1/2 plus minus 2 down below. Okay, so that's 2 because the square root of 4 is 2. But let's analyze the top. 11 itself is prime, but there's a negative 1 in there. Okay, there's a negative 1 in there. So the truth of the matter is, this could be rewritten as radical negative 1 times radical 11, because you could actually do that with negative 1 times 11 in there. You could split that apart too. And we hopefully all know that the square root of negative 1, well, that's just I. So this is I times radical 11. I mean, that's what this equals, I times radical 11. So this can become I times radical 11. And then typically if you want to write it in that like standard complex form, if you want to make it a little nicer and show your teacher that you know what you're doing, well, here's the real part and here is the imaginary part, and you could put the I sort of off to the side like that. I don't know if I did that in the final answer of the last problem, but that's a nice way of leaving the answer. Moving on. Okay, quadratic formula, very, very straightforward. Let's see. So that is x equals negative b plus minus b squared minus 4ac all over 2a. And a in this case is 1, b in this case is negative 1, and c in this case is also negative 1. Now, how did I get 1 for a? Well, that's the coefficient of the first term. How did I get negative 1 for b? Well, that's the coefficient of the second term. How did I get negative 1 for c? Well, that's the constant that's at the tail end. Okay? So all you have to do is then just like literally plug it in to the quadratic formula. So I'm big on the empty parentheses, as my student knows. So I'm just going to write that because I know there's going to be stuff in there. That's going to be 2 times some number, and then we're going to have negative b. Well, b is negative 1, so negative 1 goes here and here. A is positive 1, so that's going to go here and here. And c is negative 1, so that's going to go here. So then, simplifying it further, we're going to have positive 1, because obviously negative 1 is positive 1, plus minus, and we're going to kind of go about this next part slowly. The 1 squared is obviously positive 1, so that's going to be 1. And then once you square this first thing, pause and just take a look and just ask yourself, I have a negative times a positive times another negative. Will that be positive or negative? Well, it turns out that a negative times a positive times another negative is going to be positive. So then you just write plus there, okay? Then you ask yourself, well, what is 4 times 1 times 1? Oh, it's 4. So you just write 4. Okay? And then it's going to be 2 times 1 down below, so that becomes that. And then it becomes x equals 1 plus minus radical 5 all over 2. And, that could be the answer, depends on like the textbook or the teacher. Where your teacher wants you to stop with that. But, you could always sort of write it as 1/2 plus minus radical 5 over 2. That's a possibility as well. You could always split that denominator. All right, now in case you're not sure like what the heck I did there, well, think about it. If I went from here, I could go here, correct? Because I have a, common denominators, 2 fractions with common denominators. Now, if I add them, what do? Well, I keep the denominator and I add the numerator. So certainly my student at home would realize that I can go from here to there. So for the same reason, I can go from here to there, and some textbooks will feature that as the final answer. Moving on. This is also quadratic formula, so it's going to be x equals negative b plus minus b squared minus 4ac all over 2a. And let's find out what our a, b, and c is over here. Now before you do that, you actually have to set it equal to 0. So you got to be super careful with that. You got to set it equal to 0. So we're going to have this minus 12 equals 0. Clearly a is 4. There are no GCFs to factor out, so unfortunately we're stuck with these coefficients. B is 3 and C is negative 12. And once again, just sort of going through the motions of writing the quadratic formula. Right there, minus 4 times a times c all over 2 times a. And what belongs in there? Well, b is 3, so that goes here and here. A is 4, so that goes here and here. And c is negative 12, so that goes there. So we're going to have x equals negative 3 this time. Negative 3 plus minus 9, and then I pause, and then I ask myself, negative times a positive times a negative, well, that's going to be positive, so it's going to be 9 plus something. And then I ask myself, well, what is 4 times 4 times 12? Well, 4 times 4 is 16, and 16 times 12 is 192. And that's going to be all over 8. So that is what that one is. And then we have negative 3 plus minus, well, that would be 201 all over 8. So the question is, could this be simplified? Does 201 have any perfect square factors? And if so, that we could simplify it. Well, it turns out that it does not. 201 has the factors of 1 times 201, obviously gives us 201. And also 3 times 67 gives us 201. In neither case are there any perfect square factors, so we are stuck with that. Unless by the way, for my student at home, of course maybe I'm making careless mistakes, or I might be making careless mistakes, so I'm kind of just doing this on the fly, and I'm kind of doing it quickly to save time. But as long as my student at home understands the general gist of it, I'm happy with it. But so far, obviously I think I'm right so far with everything. But let's take a look at this. Negative 3 plus minus. It's going to be negative 3 over 8 plus minus radical 201 over 8, because you could split the denominators. All right, moving on. Okay, so we have negative 2r squared plus r plus 17. So let's once again set it equal to 0. It's going to be the same deal where we're using the quadratic formula. Now the thing is, I don't feel like dealing with the negatives, like negative a. I don't know, that's just me. Maybe that's stupid. It really doesn't matter, I guess. But I'm just kind of in the habit of just getting rid of any negative leading coefficient. So I'm going to divide everything by negative 1. And that's going to give me 2r squared plus r plus 17, and that equals 0. Okay, I don't know why, because I'd rather deal with positive numbers. So once again, using the quadratic formula, I'll just kind of do it right away. It's going to be x equals negative something plus minus something squared minus 4 times something all over 2 times something. Well, this is going to be b, so it's 1. That goes here. A goes here, and c goes here. Going through the motions once again, we're going to have x equals negative 1 plus minus, let's take a look at this. 1 squared is just 1. Now we're going to have a negative times a positive, so that's actually going to be negative right there. So that's going to be negative right there. So then the question is, 4 times 2 is 8, and 8 times 17 is 136. 136. And that's going to be all over 4. So when we sort of work with that one, it's going to be x equals negative 1 plus minus negative 135, and that's going to be all over 4. Now, we are almost done. We have negative 1 plus minus Let's see if we can simplify this. Well, first of all, there's a negative in there, so we know there's going to be an I involved. However, 135, does that have any perfect square factors? Let's see. Turns out that it does. It turns out that negative 135 is really a result of negative 1 times 9 times 15. And this 9, right here is a perfect square factor. So we got to take that into account. And then we're going to have a 4 down below. And then analyzing what happens here. We still have that negative 1. It's going to be plus minus. So due to the 9, we're going to have a 3 on the outside. Due to this negative 1, we're going to have an I on the outside. And then we have radical 15. That radical 15 is just stuck there underneath. And then that's still all over 4. So if we were to sort of split that, it would become negative 1/4. That's actually the real part. Plus minus 3 times radical 15 over 4. And we could put the I off to the side. All right, so if my student is confused about that, he could always pause the video and rewind it, or just kind of look at these two steps and realize that these are two ways of saying the same thing. Now, I do have a funny feeling that my students wanted me to go over a particular kind of completing the square problem, and we actually didn't go over it, so I'm going to go over it right now. So what happens when you have something like 3x squared minus x, we'll say plus 4 equals 0. Well, that is a little bit of a tricky situation because before, the completing the square problems that I did before featured a quadratic trinomial that had a GCF that I could just factor out of the whole thing and turn it into a more like easy completing the square problem. This one's going to be a little bit different because we're not going to be able to get rid of that 3 right there. Okay, that 3, we're kind of stuck with it. And you do have to do things a little bit differently when you're completing the square and you have that leading coefficient right there. So what you have to do is, first of all, go through the same thing that you did before, where you send this like 4 over to that side. So this is going to become 3x squared minus x equals negative 4 after doing that. But then you have to be careful. You have to then look at these two guys. And since there's a coefficient, a leading coefficient, the absolute value of which is greater than 1, you actually have to do something different here, where you have to factor out this leading coefficient from both of these terms. And in doing so, you're going to have 3 times something equals negative 4. And what is that something? Well, 3 times what gives me 3x squared? Well, obviously 3 times x squared gives me 3x squared, right? And then I got to ask myself, 3 times what gives me negative 1x, okay? That's kind of tricky. 3x times what gives me negative 1x? Well, that's going to be a negative 1/3. Okay, x. All right, negative 1/3 x. That is going to give me this. My student at home has to pause the video to make sure that that checks out. Then please do so, student at home. Okay, now what do? Well, we have to just leave this guy hanging out over there. You're just going to leave this alone. You're going to keep it there. And we're going to worry about that later. But now we have this other thing that we have to deal with now, where it's, really x squared minus 1/3 x, and I really just rewrote this, but now I have a space here. And that space is where the new number that we bring into play is going to go. Now, how do we get this new number? Well, you take this middle coefficient, which is, negative 1/3. Negative 1/3. You divide it in half. So that's going to, divide it by 2, and that's going to become negative 1/6. And then you square it, and that's going to become positive 1/36. So that's what you put right here, plus 136. And then you have to put it over here. But here's the problem. In reality, even though we went through all these motions, we divided negative 1/3 by 2, which gave us negative 1/6. We then squared it, which gave us positive 1 over 36. Well, what did we really add to this left-hand side? It's only an illusion that suggests that we added 1/36. The truth is, we added 1/36 times this 3. So, because this 3 would hypothetically get distributed into the whole thing, we really added 1 over 36 times this 3. Now what is that? 3 over 36 is 1/12. That's what we added. And in case you have to double check that, 3 times 136, which is going to be 3 over 36, and 3 over 36 is 1/12. So actually, by adding this yellow thing, we added 1/12 to both sides. So I'm not going to write 1 over 36. I'm going to write plus 1/12 on this side. Okay, so that's what's tricky about these. Okay, now what do you do from there? Well, again, you keep this 3 on the outside, but now you can factor this and turn it into x. And then what? What is this number? Well, remember, it's the first thing you got when you divided the middle coefficient by 2, negative 1/6. That's what goes there, negative 1/6. And then we end up with, 4 plus 12. Now let's be very clear. 4, I'll put an asterisk there. 4 is secretly equal to 48 over 12. Okay? Because 48 divided by 12 is 4. And it really should be negative. It's negative. Okay? Because that's a negative 4. That's what we're looking at. So it's true that negative 4 is secretly equal to negative 48 over 12. And the reason I do this is to get that common denominator. So we're really going to be adding negative 48 over 12 plus 1/12. Well, what is that? Well, first of all, it's going to be negative, right? It's definitely going to be negative. And it's going to be negative 47 over 12. All right? And then when I go through the motions even more, I can then divide both sides by 3. Divide by 3, that cancels the 3's. And then I'm left with x minus 1/6 squared equals, well, anytime I divide a fraction by 3, you could just multiply the 3 times the numerator. So that's going to become, we'll keep the numerator negative, so that's going to become negative 47 over 36. And then when I do the square root of both sides, it's going to become x minus 1/6 equals plus minus radical 47, negative 47 over 36. And this radical applies to the top and bottom. And it turns out that there is some simplification that could be done here. I'm going to get to that soon. First, let's add that 1/6 to both sides. So we're going to take this all the way up here. So after adding 1/6 to both sides, we're going to have 1/6 plus minus the whole thing of radical negative 47 over 36. Now, as I said before, this right here could really be rewritten as radical negative 47 over radical 36. Radical 36 is really straightforward. That's just 6. So on the next line, I'm going to write 1/6 plus minus radical negative 47 over 6. Now, as my student at home is watching, he probably understands that there is a negative here, so that means I could get factored out. So on the bottom, I'll just rewrite it as x equals 1/6 plus minus radical 47 over 6, and we'll stick the I over here. Now, as far as 47 goes, that actually does not have any perfect square factors, so we are stuck with this 47 underneath the radical symbol. Hopefully that makes sense. For my student at home, good luck on your test. And for those of you who watched the video, hopefully this makes sense. And I will talk to you all later.